Okay, this is lesson 7 of module 2, and we are on the next topic. So we've learned about some transformations in the plane. We've learned about translations along a vector. We've learned about reflections across a line of reflection. And we've talked about rotations around a point of rotation. Okay, and they all had a lot of things in common. We saw that they all had the property that when I transformed a figure, such as an angle, it was transformed into a figure of the same size, same type of figure. So angles were mapped to angles, rays to rays, segments to segments, lines to lines, and we learned that that the measurement is preserved. So the size of the angle, the length of the segment, and such are the same under translations, rotations, and reflections. Okay, so in these next 4 lessons, 7 through 10, you're going to be doing not just one transformation, but several in a row. So sometimes it's necessary to do more than one translation. And so in this first lesson, lesson 7, we're going to go back to translations, and we're going to look at a sequence of translations. And then in lesson 8, we'll do reflections, and then we'll do combinations of translations, reflections, and rotations. So it gets kind of fun. It's a little bit like a puzzle by the time we get to the end of this. But we're going to start fairly simply here today. So I think this is going to be a fairly short video. And I just want to start by looking at an example, and then we'll do some exercises together. Okay, so here is a diagram. And in this diagram, you have an original figure, E, and we have a couple translation vectors. We've got AB and BC. So you can see that E was translated along AB. So it was moving in this direction, this amount of length, right? So it goes from E, here's the image E prime. And then I'm going to take the image E prime, and I'm going to translate it along vector BC. So it's going to move upward and not quite as far, about half as far, and it'll move upward. And you notice the notation here, we've got E double prime. So we're going to use the double prime to show that this figure's been translated twice, okay? Same thing with this point. Here's point P, was translated along vector AB for P prime, and then along BC for P double prime. So those are the, that's a sequence of translations. Okay, so we're going to do it. I'm going to get you started on exercise 1, and then going to let you work on exercises 1 through 4. Okay, so in this first exercise, exercise 1, we have several directions down here. And we're told to translate triangle ABC and segment ED. So here's not triangle, but angle ABC and segment ED along vector FG. So I got to find vector FG. It's right here. And label the translated images appropriately. In other words, A prime, B prime, C prime, and E prime, D prime. And then in part B, we're going to take our image, whatever we got when this was translated, and we're going to translate it along vector HI. Okay, so it might be fun for you to try and predict where these images are going to come out in the end, but let's do this together, and then I'll let you answer the questions. Okay, so in order to translate this angle along vector FG, I want to trace the vector on my overhead. So I'm using my overhead now. I've got vector FG because I'm told to translate on FG first. And then let's put my figure in a different color. and I've got angle, I've got points A, B, and C, and then segments between them forming an angle. Okay. Go ahead and label these A, B, C. Okay. So now, remember how we translate along a vector. We're going to move the overhead so that F lines up with point G. And so we're going to come along here, along this vector. And remember, if it helps you, you can draw a line extending vector FG, and that can help. Okay, so I'm going to go ahead and copy this. Let's make sure I got it in the right place. Copy, that'll be my point A prime right there, B prime, and C prime. Okay, so go ahead and label those points. A prime, B prime, and C prime. Okay, so that's a translation along vector FG. And I'm going to go ahead and connect the points. I think this is a little bit easier way to do it than just freehanding it. So I'll connect those points. And I'm probably going to be asked some questions about the measure of this angle. Okay, so there's my translated angle, translated along FG. Now I was also told to translate the segments. Let's go back and do that. So there's my vector. I've already traced it. Now I'm going to trace the segment here. I'll put the segment in black. Segment D, E. So there's E and D, point D right there. So once again, I'm translating along this vector, okay, not along the segment or anything. I think some of you are getting tripped up by that. So I always move in the direction and in the distance dictated by my vector. Let me move back on the screen here so we can see where ED ended up. And I'm going to mark those points and then connect them. Let's get it back. That looks good. Ah! Okay, so D is right here. E is right here. And I'll connect those. So this is D prime and E prime. There's my segment. D prime, is that D? No, that's E prime down here. E prime and D prime. Okay, so you can kind of see these have moved over and down a little bit. Okay. Now, so I've done everything in A. I've done that. I've translated the angle and the segment along the vector. I've labeled it, and I'm good to go. So now, so we've done that. You did that in the early lessons of this module. Now I'm going to translate this angle, angle A prime, B prime, C prime, and and my segment, E prime, D prime, along vector HI, which is up here, which is not quite as long as vector FG, so it's going to go down and to the right. Okay, so let's see what that looks like. So let's get a new overhead, and we will, let's see if I can get this all on the screen. There we go. So my vector, I use red for my vector again. My vector I'm going to use this time is HI. There's HI, and there's the 2 points. And now I'm translating not my original figure, but I'm translating the images. Okay. And they're going to move once more down in that direction. Okay. Okay, so now I can mark these points up again and label them with the double prime notation because they've been translated twice. Let's get this one, get this one, and again, I don't claim to be doing this perfectly, but you get the point. So I've got A double prime, B double prime, ooh, where'd it go? Here's C double prime. All right, and we'll connect that. Connect those and get our angle here. And here's E double prime and D double prime right there. So D and E. Okay. So there's my translated angle. So I've got angles and segments all over the place on that. Okay, so what I'd like you to do is to answer the questions here. Think about those and we'll come back and talk about them, A through E. And then also move on to example or 2, exercise 2, where you're going to be translating this triangle here along 2 different vectors, one after the other. Label the images appropriately. And you can go ahead and do exercise 3, where you're going to be translating this polygon along 2 different vectors. And you can do exercise 4, and then we will come back and look at those together. So exercise 4 has you translating circle A and ellipse E and along 2 different vectors. Okay, so you're going to be looking at, did the size or shape of any of these figures change even when we did a sequence of translations? Okay, so go ahead and work on that. Okay, we're going to go over some of these exercises. Okay, so we've got exercise 1, and we did the translations of these together. So we've got this diagram up here, and we're asked a few questions. And hopefully you saw in C, how does the size of the original angle, ABC, compare to the size of A double prime, B double prime, C double prime after it was translated twice? And hopefully you saw that those measures are equal because the figure's just moving in the plane, but not changing size. How does the length of the segments, how do the length of the segments compare? They're also equal. And then why do you think what you observed in parts D and E were true? And so something similar to this, the translations moved the figures to a different part of the plane, but all measures are preserved even with 2 translations. So if it's preserved with 1 translation, this didn't change, then it stands to reason that it's not going to change when we translate it again, because we're just doing the same thing over again. Okay. So you were supposed to have worked on exercise 2 as well. The directions here were to translate the triangle ABC along vector FG right here, and then translate the image along vector JK. So let's see what that looks like. I've already drawn this one on the overhead to save a little time. So if we're right here, we're going to translate up along this vector. I'm moving along the vector to see where I end up, and I end up about right there. Now, I wonder how many of you noticed that on a coordinate plane, we have an advantage here because I can predict where these points are going to be. let's get this straight again. Right here. And here's my next point. And then the last one, get it straight here, should be right up here. Okay, so let's connect the dots on that triangle. I want to point out something about this translation vector. When we view it on the coordinate plane, something's kind of helpful happens. Okay, so this would be, what's the name of our triangle? So this is A prime, and this would be B prime. I'll label it inside, and C prime. And this vector right here is, you think of it, to go from F to G, I go over 2 and up 3. So hopefully every point on my figure is going to move the same direction. Did you notice that? Let's look at C. It goes over 2 and up 3. B should go over 2 and up 1, 2, 3. And then A goes over 2 and up 1, 2, 3. Okay, so that's one way to use a translation vector on a coordinate plane without having to use your overhead. So whether you use the overhead or not, if I use translation vector JK right here, notice that's a translation over 3 and up 1. So let's see what that looks like. 1, 2, 3, and up 1. And B should go over 1, 2, 3, and up 1. And then, so this is C prime, B double prime, sorry. And A should go over 3 and up 1. Over 3 and up 1. So there's my second, my double prime is right over here. And we'll notice that the triangle is the same size and the same shape. And that's what we're looking for. And that's what we're going to use these translations for. Same size, same shape. These are congruent figures because a sequence of transformations will map them onto one another. So this, A double prime. So the original figure mapped here, this one mapped here. Okay, those are done. Okay, let's look at our next exercise. This was exercise 3. See if I can focus this a little better. We have this polygon here. We're translating it along GH, right here, straight down 2. And then we're also going to translate it along JL, which is over 1, 2, 3, 4, 5, and up 2. Okay, but we can use our transparency here. And, you know, I think for this one, I'm just going to show you what you should have gotten. I've got it right here. Let's look at this result. Okay, so I've got my original right here. When it was translated once, it went straight down, translated along this vector right here, GH. It became this figure down below. Every point moved straight down 2. So C moved down to C prime. Everything moved down, okay? Then I went from this figure along this vector, and it moved everything over 1, 2, 3, 4, 5, and up 2. So F went over 1, 2, 3, 4, 5, and up 2. So this is my double prime figure over here, okay? So that's what you should have gotten. You should have labeled these as the double primes. This is, what is this one? E double prime and D double prime, E double prime, F double prime. Gosh, I can't read this. This is B, I guess. However you label it. These are all the double primes right here. A, B, C, D, E, F, yeah. And this was our prime figure. A prime, B prime, C prime, D prime. And you should be noticing that these are all the exact same shape and size. Okay, so that's exercise 3. And now we'll look at exercise 4. Maybe we'll do this together. Now this one, we don't have the coordinate plane to help us, but we can still work on it. So I'm supposed to translate circle A and ellipse E along vector AB. So think about what vector AB is going to do to these shapes. It's going to move it straight up this distance. So translated circle A should be up here somewhere. Translated ellipse E should be right above itself right there. So let's go ahead and do it. I don't have a lot of field of view right now. So we're first using vector AB. So I'm going to trace AB. And let's get circle A here. Label it A. And ellipse E. So I'm going to go ahead and trace out ellipse E. And we'll go ahead and translate those. I'm going to move my paper down as I move my vector up. And looks like they're just overlapping a little bit. The circle is overlapping, the ellipse is not. Okay, so we moved them up. Let me go ahead and trace those in red since I have a red vector there. This is kind of hard to do, but it is an overlapping circle there. If it comes up. Like some of you saw you could use. Okay, that doesn't look beautiful, but there we go. So along our vector AB, we get circle, call it A prime, right there. Translated figure A, call it A prime. Okay, and now we are going to translate, let's get our ellipse on there. Doesn't have to be beautiful. Okay, so there we go. So there's the A prime, and translated ellipse is E prime. Okay, now we're going to use this other vector here. Feel free to play this in double speed if it helps, if you know what you're doing here. Or even fast forward. All right, so we got a clean overhead sheet again. We're going to trace out vector CD. And this time we're going to translate A prime. So it's this circle and this ellipse. And we're going to translate it along vector CD. Okay? So again, I'm focusing, when I do the translation, I focus on the vector, not the figures. I just let them move. Okay, so I've moved along that vector. Let's see where they ended up. Right over here. So I'll go ahead and trace this in blue. Something like that. And my ellipse is over here. Right up here somewhere. Okay, pretty close. Okay, so this would be E double prime. on that, and this is a double prime for this circle. And let's go ahead and make this vector blue like so. Okay, so my new series of shapes looks like that. And part C says, did the size and shape of either figure change after performing the sequence of translations? Once again, no, it didn't. Hopefully we're convinced by now that the sequence of translations does not change these figures. Okay, so why would we want to do a sequence of transformations anyway? Well, there are times when we want to map a figure to another figure, and we're going to be doing that to prove congruency, to prove that two figures are congruent. Sometimes we actually want to map a figure back onto itself, and so let's look at what that would look like. So here I have figure D right here. I'm going to trace it, and I'm going to translate it along vector AB right here. Oops. Translate it along vector AB. That's kind of a long way. Okay, so I'm going to slide it over until my beginning point here matches the ending point of the vector, and there's my translated image. And let's go ahead and do it. We'll do it in blue. Okay, so it just moved it straight over like so. Okay, now if I wanted to map, so this would be D prime. Now what if I wanted to map D prime right back onto itself? What vector would I use? Okay, I used vector AB to get it from here to here, vector AB. So vector, what if I used vector BA? Vector BA should take it back where it started. So we'll look at that. So this time, let's get on here. So this time I've got I'm going to start with my translated figure. I'm going to translate it along vector BA this time, which means I'm going to take point B and move it to A. Whoops, I've got to trace my vector. Like that. And I'm going to move it along here. And it moves it right back on if I, with a little bit more precision, it would be exact, right? So that's something that is useful in doing these sequencing of translations as well, is we want to do that sometimes. Okay, let's look at exercise 5. And we're just going to talk through this. I think we can do this pretty quickly. Look at exercise 5. Here's the diagram, and I'll bring the picture, the question here. The picture shows the translation of circle A along vector CD. Moved it down and to the right. Down, over, and like that. Name the vector that will map the image of A. This is the image of A back onto itself. So what vector would do that? So think about that. Pause it if you need to. Okay, so if CD moved it down, vector DC from here to here should move it back. Okay, and you can try it. You can try it if you need to. I'm not going to do it on the video. So if a figure is translated along vector QR, what translation takes that figure back to its original location? Pause if you need to. But the opposite vector would do that, right? It would be vector RQ. Okay, so let's summarize what we've talked about today. we've gone back and done some translations. So hopefully if you were still shaky on translations, you know you've had a lot more practice with translation along a vector. Especially even in the coordinate plane where you might not have noticed before the correlation to the over and up movement of a vector and how that translates into each point moving over and up, or to the side, up and down, and left and right along a vector. So we've done that, and we've seen that translating a figure along one vector and then translating its image along another vector is an example of a sequence of transformations. So we did this, we did them two. You could do more. Two is not the limit. So you could even do more than two. All right, so we saw a sequence of transformations. A sequence of translations we saw enjoys the same properties as a single translation. Specifically, the figure's lengths and degrees of angles are preserved because we're just moving around the plane, but we're not shrinking it or enlarging it in any way. We're not moving things around within the figure itself. So all of the lengths and measurements are preserved. If a figure undergoes two transformations, F and G, and is in the same place it was originally, then we can say that that figure has been mapped onto itself. And so we saw that with the example of the little teardrop example where the figure went from here to here and then back. And actually we should have labeled this D double prime, which is the same as the original figure, because we went from A to B and then we went B to A, and it took us right back. Okay, so, and the language we use for that, the language we use for that is that the figure has been mapped onto itself. Okay, you are now ready for your exit ticket and your problem set. Now, I did want to point out one thing on this exit ticket. It talks about naming a translation that would map a figure onto itself, or no, that would map a figure onto another figure. They've given you some vectors here to use. So make use of these vectors right here as you do the exit ticket. Okay, good luck and have fun, and happy Friday.